Today we're going to talk about maps, and we'll start with some news. So this was the two candidates for selecting the New York subway map in 1978, and the difference were kind of philosophical, like should you have a map that's very close to the land reality or something more schematic? And the reason why this is news is not because it happened in 1978, but because 2 weeks ago, the same people that worked on those maps and debated about those maps met again, and the topic of the debate was, do these maps even make sense now when we all have smartphones in our pockets? Because when was the last time that you took a map like the left one, instead of just asking Google Maps how you would do your itinerary? So since it was a debate, there was no definitive answer, but I think it was interesting. And another map, again, 2 weeks ago, this was made by refugees in Germany, and it was made for other refugees. And the goal was to offer them information about where to find a doctor, when to find police services or legal services. And so yes, as you may have seen in some reporting, they have smartphones so they can access this map, and you don't have a physical map that's never updated. They all have this map, and they can use it in Berlin. So the reason why I talk about those maps is that we can see that there are two kinds of maps, and the first type of maps I presented, the subway map, was I want to go to this place, and I'm here, and how am I going to plot my itinerary across the transportation available to me? And the second type of maps is putting data on a map, and it's more an infographic, if you wish. And actually, we're kind of moving from the old type of maps, which we know how to do, and we've done quite a lot, and it's something that kind of solves problem. And now maps are used for more representing information. And for example, Yelp or Foursquare are just about putting information that you can access on a map. And so we are more going to talk about the second kind of maps today. So first, where are you going to get the data that you're going to put on your map? So first, when you meet a data set, these are the kind of metrics that you are going to want to evaluate. So this is taken from big data, but since we're working on mobile, it can also make a difference for you. So volume is how much data you have. Velocity is how fast the data you get comes. For example, if you're using Twitter, you get a lot of tweets every second. But for maps, that's not going to happen. Variety is about in how many formats is your data available. And veracity is about how much you can trust your data. So in our case, it's mostly about variety, because we're going to pull data from a lot of places and try to use all those data types and try to make a coherent map of all. So some samples you can use. Since we're in Paris, I'm going to mostly use examples centered in Paris. So now a lot of cities are offering open data about every information you can get on a city. So transportation, or here you have a few examples of like museums or green spaces, or the list of all 145,000 addresses in Paris. And so these are data sets that you can use and include on your map or put on your backend, and then use an API for your application to access it. And the thing is, the government has been doing this for a few years, and those data sets are not very used. So there is a huge opportunity, just to extract all this data and do something about it. On those examples, they all have been downloaded around 200 times, except for green spaces that has been downloaded 3,500 times. I don't know why green spaces is so popular, but this one particularly. You can, like I said, use Yelp or Foursquare if you want data about shops, for example, if you want opening hours or things like that. And a huge source of mapping information is going to be OpenStreetMap. This is kind of Wikipedia for geographical data, and you'll find a really tremendous amount of data. And here you can see this is Notre Dame, and you can see that they even have a drawing of the building, which, fun fact, they're using the API for streets for drawing the outline of a building, because in both cases there are collections of points, and they already had streets, so they said, well, this is a street. And here you can have the name in several languages, opening hours, and a lot of information. And actually, you can have a lot more information than that. You can also have 3D buildings through OpenStreetMaps. And here is Google Maps. The way you get this in Google Maps is by just using the camera and tilting it. You can start to see 3D buildings. So on the left is OpenStreetMap, and this is actually quite recent. It's a library in JavaScript using OpenGL. Well, WebGL actually, that's been out for a month, I think. And so you can see, I don't know if you see well in the back, but for Notre Dame you have each part of the building that's very, very precise. You know, each tower, each document, and for OpenStreetMap has information about what type of materials, what type of roofs, and actually it starts to get a little bit complicated if you want to start and read all of this data. And finally, really good and use that a lot of us have used is about transportation data. For example, the most popular example in Paris is about Vélib, the free bikes. And actually, the standard for transport publication is called GTFS. It has been designed from Google. And it's not the kind of data we used to see. We're mostly used to JSON or XML. And this is a zip archive of CSV files. And these are the mandatory files that you need to have to match the standard. So you need to have the companies that work there, all the stops on your area, the routes you can do, and the trips, etc. And you also have optional data types that are provided, like how much transportation is going to cost, or what kind of lines can you transfer from and to, and even shapes like drawing your transportation on a map. And actually for for Paris and suburbs, this has been out since October 30, so 2 weeks ago. This was made available by STIF, which is the regulator for public transportation in Paris and suburbs. And they made this available through Navicia, which also works in a lot of different cities around the world. And the one thing on top of variety, velocity, and veracity we saw earlier is about the licenses you're going to use, of the data you're going to use. So some are very free, like EtaLab, which is a governmental mission that makes open data for the government, which is an open license, and the only thing you have to do is to say where your data came from, and others are more constraining. For example, they use copyleft licenses, which means that if you modify the data, you have to make it public afterwards. And some are, like I was talking about transportation earlier, I didn't even find the information about the license for the moment. So kind of the most tricky point you're going to be concerned with. Okay, so a lot of talks about data. Now we're going to talk about how we're going to put it on the map. So, first recommendation I'm going to make is that this is a project from Airbnb, and what they're doing is that they're abstracting the Maps API. So the idea is that you interact with AirMapView, and in the background, AirMapView will interact with Google Maps if it's available on your phone. So if you can run an AirMapView on a phone that doesn't have Play services, and we will use Google Maps Web, for example. Or you can use Mapbox, which is proprietary and runs on top of OpenStreetMap, for example. But this allows you not only to work on devices that do not have Play services and Google Maps natively, but also, since you have an abstraction between your maps and your code, you can test and mock or spy what kind of map APIs you're going to use. Okay? So first representation, the easiest, is just putting a marker on a map. And actually, most of the time, you're going to want to put a list on the side. And one thing I don't see quite often is putting just, a compass showing in which direction it is. Because this is kind of, most of the time, you only see the distance, but you kind of want to know if all these points are in the same direction, for example. Maybe you can start going there and pick your place later. So this is the most basic example, and we're going to go for more complex. So if you start having a lot of markers on a map, you can have some very serious performance problems. But, so one solution is to use clusters. The way it works is that you just put all the clusters that are near one another in one big bundle, and since you have less markers on a map that are visible at one moment, you will have less performance problems. But it's like cryptography, you should never do this on your own, because you might end up with the cases on the right where your points are just put on a grid and it doesn't represent any relevant information about where the points are. Okay? Whereas on the left, you see that you have a 50 plot, so there are a lot of elements in this area. You can see it very visibly, whereas here, you just see a grid and no information whatsoever before you zoom in. Okay? So this is made available in Google Map Utils on the left, so you can use this with your maps. And actually, the API is quite simple, and so if you start having, I don't know, 200 or 2,000 markers, you could start using this. Now, maybe you want to show something other than just a pair of lat-long coordinates. And so this is the administrative sectors from Paris. They are called by arrondissements. And the way it works is that you have several standards, because like XKCD says, when you should have one standard, you already have half a dozen. And so Paris data uses GeoJSON data type, which is the most popular I have found. Navisha, which is for transport, uses WKT, which is for well-known text. And you also have KML, which has been designed by the company which used to make Google Earth because, before Google bought it. So all of this represents how you can do areas on a map, and then you can put it represented like that. So this uses polygons, which can be drawn on most maps. As you can see, the code is extremely simple. Actually, there's one trick, is that here is a sector that has a very complicated shape. So this is not convex. And by default, if you use a polygon, you're only drawing on a map. And the question is, when you want to hit on it, you want to get that the person has clicked on this point on the map. So there is a very simple algorithm to do that, to know if a point is inside a polygon. The way you do it is that you start from your point, and you just draw a ray in any direction, and you count how many edges of the polygon it intersects. If it's pair, it's outside. If it's impair, it's inside. Okay? So just a little trick to know. And then you can use another type of representations, which is heat maps. So this is public toilets in Paris, of which there are many. And you can see that it's a much more visible representation than clusters, because you really have a notion of where there are a lot of points and where there are a few. And you can see that when you start to zoom in, you can start to see individual points. But I think the most interesting representations are on the left and the middle. And then when you start really zooming, you can switch to markers according to the zoom level or the amount of data you have on your view. Okay? And actually, so this is how you do it. And the way it works is that you use a tile overlay. So it's displayed on top of your current map. And this is once again provided by Google Map Utils. But you can do more interesting things. So this was offered as a submission in a contest using open data. And it's a web app, so it's not a mobile app. But the way it works is that you can see the spots where there are a lot of transportation available. So the really heat spot in the middle is Châtelet. And on the upper left, you have Aubert and Étoile and things like that. And you can see all the train stations, which are Gare du Nord or Gare de Lyon or stations like that. So this is the kind of thing you can do with a heat map. And another example is called Isochrone. So this is a website, and it shows you how fast you can get to points from a given point. So this is centered on this conference center. And you can see the axis on which you can access data, on which you can access easily. So green is 15 minutes, yellow is 30 minutes. And so you can have an idea of where you can get fast. So for example, if you're looking for a new place to stay, you can use this to see if your work is inside or if your relatives are in this kind of areas. Okay, so my recommendation is that if you have a few data points to put, use markers. If you start having more, you use clusters. And if you start to have really a lot, you can start to use heat maps. You will still have performance if you're starting to put, I don't know, 2 million points on a smartphone, but this will alleviate a lot of the complexity and the performance issues you can have. So these are a few links. So AirMap view on top. From what I showed currently, AirMap view can do the markers and they can't do heat maps, and I'm working on the GeoJSONs. So I have pull request apps for that, so polygons and GeoJSONs. So the one thing missing is heat maps, since it uses tile overlays. It's a little more tricky to do on web views and such. Android Map Utils, which is open source, which is not the case of Google Maps, so you can really start to go inside and see how they do their clustering or how they do their projections and things like that, and it's very, very interesting. All the screenshots I've taken that come from an app are available on GitHub if you want to access them and start playing with them, and those slides are also available. Do you have any questions? I believe we have some time.